Hi, my name is Darla Moore, and I work at the McGeehan headquarters in Cleveland, Ohio, and I'm going to be explaining to you the step-by-step process of titrating for a J-84 sample solution. So what I'm going to do is I'm just going to pipette 5 milliliters straight from the sample bottle, and you want to usually sample from the center of the solution. That way you don't get anything that may be sitting on the top of it or in the bottom of the solution. And then go ahead and wipe off the pipette. I don't have any excess solution in there. And drain it to the mark that's on the pipette. I have exactly 5 milliliters. Put it in the Erlenmeyer flask. And go ahead and move the pipette just because it helps it drain faster sometimes. I'm just going to give it a little tap. Now we're going to take the 5 milliliters of solution and we're going to dilute it with deionized water. And you can dilute it to either 50 mils or 100 mils, whichever is your preference, so that you can just see the color change in the titration that we're about to do. But what you want to make sure that you do is rinse down the walls, the inside walls of the Erlenmeyer flask, just to make sure that you got all of the sample down into the bottom. And before you pipette the sample into the Erlenmeyer flask, you can go ahead and put a stir bar in the bottom of the flask, which will be utilized during the titration. Okay, now we're going to use a 50 milliliter burette filled with a known volume of a 1 normal sulfuric acid for the titration for the alkalinity of our sample. We're going to start with 3 to 4 drops of the phenolphthalein indicator. I'm just going to put that directly into the Erlenmeyer flask. I'm going to change the solution to either red or pink color. And now we're going to place it on the magnetic stirrer under the burette. You want to place the burette tip in the middle of the Erlenmeyer flask. And then you're going to turn it on to a steady volume, which will stir the solution. And you don't want it to stir too fast and splash the solution on the sides of the wall. Just enough that it's agitating the solution at a good rate. You're going to open the burette and you're going to titrate with the 1 normal sulfuric acid until the pink color dissipates. And as you get closer to the end point, you'll see that the color will start to be a little more faint. And you can slow down the burette to dripwise. That way you don't go past the end point. Turn the stirrer off, and you will record the volume, the milliliters volume used out of the burette, and use that to calculate the alkalinity of the sample. We're going to move to the second part of the test for the J-84 solution, which is going to be testing the sequestrant of the solution. And we're going to pipette first another 20 ml sample of our solution, again from the center of the sample bottle, and we're going to place it into this 100 ml graduated cylinder. And again, make sure that you wipe off the pipette so you don't have any excess solution going into the cylinder. J-84 solutions can be a little viscous, so you might want to give it a little extra time to drain out. Give it a little. Now, using the information from the alkalinity portion of this test and the calculation that is on the data sheet, we're going to take the milliliters of sodium hydroxide that were utilized to find the end point of the solution, and we're going to take the milliliters times the factor 0.21 to get the amount of 50% by volume sodium hydroxide that we're going to have to add to this 20 ml sample, and that is just to bring up the alkalinity of the solution for the sequestrant portion of the test. And this volume that's added does not have to be exact because you're only making the addition to raise the alkalinity of the solution. For the next portion of the test, we're going to be placing the 20 mils of the sample with the added 50% sodium hydroxide into a hot water bath. We have the hot water bath set up here. You want the sample to reach 180 degrees Fahrenheit. You want to make sure the water inside the canister is going to be above the level of the solution so that you can thoroughly heat the whole solution. So you're just going to take the sample and give it a little swirl to mix the sodium hydroxide with the sample, and then just place it directly into the hot water bath for heating. The sample should be at 180 degrees Celsius now. So what we're going to do is we're going to remove the sample from the bath. And at this point, we're going to add in 1 milliliter increments a 1 molar ferric chloride solution. What we're going to do is we're going to add 1 milliliter to the sample. And you're going to want to record the amount of milliliters that you add to each sample so that you don't get lost. We are going to add a stopper to the top of the cylinder, and you also may want to use a thicker paper towel to cover the top. You want to make sure that this is held down tightly. So we're going to put the paper towel over the stopper and wrap it around the cylinder because the solution is at 180 degrees. And what we're going to do is we're going to shake the solution to mix up the ferric chloride with the sample to see if we have any red precipitate that forms in the bottom of it. After quite a few shakes, you're going to want to slowly release the pressure that's in the cylinder, and it is best advised to keep the paper towel covering the stopper because it can release some solution. At this point, you can place the stopper back on firmly with your thumb over it and shake it a little more. As you can see, the J-84AL samples do have a tendency to foam an awful lot, some samples more than others, so you want to be extremely careful when removing the stopper from the cylinder that you don't release any of the solution. And now we are going to check in the bottom of the graduated cylinder for any red precipitate, which will be the ferric chloride falling out of the solution. For this, it's usually best to use a high-intensity light or a high-intensity flashlight. I do not recommend the LED flashlights because they create quite a glare off of the glass. You just want to take your flashlight and you're going to lift the cylinder. Be careful not to spill any out, and just look in the bottom of the cylinder to see if there are any red precipitate flakes in the bottom, which there are not. So at this point, we're just going to keep repeating this step of adding 1 milliliter of ferric chloride to the solution, tapping it and shaking it until we see a red precipitate in the bottom of the cylinder. This process of adding the 1 ml increments of the ferric chloride to the solution and shaking it can go on for a number of repetitions until you see a permanent red precipitate in the bottom of the cylinder. At this point, then you would add it back to the hot water bath. Right, after heating the sample back up to 180 degrees, we're going to go ahead and remove it from the hot water bath. We're going to go ahead and place the stopper back on the cylinder. And again, give it a couple good shakes to mix the solution. Also, at this point, you may see that the foam is taking on a darker color, which means that you're closer to the end point. I'm going to go ahead and carefully remove the stopper. And use the high-intensity light or flashlight to check for the red precipitate in the bottom of the cylinder. We now see that the red precipitate is persistent in the bottom of the cylinder, which means that you have reached the end point of the sequestriant test. After completing both the alkalinity and sequestrian portions of the J-84AL test procedures, we can take the data obtained from the test and apply it to the calculations found on the data sheet for the specific product. All of the Cee-Bee data sheets can be found on the McGeehan website. For the alkalinity portion, we are just going to take the milliliters of sulfuric acid used in the test, times it by 1.6, which will give you the fluid ounces per gallon of J-84AL based on alkalinity. For the sequestrian portion of the test, you're just going to take the milliliters of ferric chloride times 4.8, which will give you the fluid ounces per gallon of J-84AL based on sequestrian. Using these numbers, we can use further calculations found on the data sheet to obtain the amount of additions we want to make to the tank to bring the solution up to optimum.